I suppose I could make a start on that at least.
Thanks, Jonathan. We probably need someone in the room as well, but that would be very welcome to have the agenda put in. Jörg, okay. Thank you, Jörg. Much appreciated. So we have a note taker. And I guess it's time to introduce myself. I'm Gori, if you haven't met me. We're the helpful and very kind TSVWG chairs. Please talk to us. We'd love to talk to you about anything related to TSVWG. This is Martin. Martin, do you want to say who you are? Yeah, he waves.
Hello, I'm Martin.
Okay, let's go.
Why can't I select this? I can delete the slides, but I can't pull up the slides. This looks better.
We all know this. We should know this. This is the note well and indication of the policies we have in the IETF. This is Tuesday. If you haven't yet read these, please look at the IPR and the policies we have around how we run the IETF. This is important. It relates to you, it relates to how you talk to others, and it relates to the contributions you bring to this meeting. We have more small print here. But all of this, if you haven't read it, please look at it because it is important to the conduct and operation of the IETF to ensure we do the right things and everybody helps one another. It also refers to the Ombudsman, who is our recourse if we feel something is not going well. Next slide. Please help TSVWG. We have a note taker. We're pleased. Thank you for people taking notes. If you plan on contributing something to this working group, we do have opportunities for people to submit new drafts. If you plan to do that, please include TSVWG in the name of the draft, after your own name, and please send it to the list so it can be discussed before the time when you want it presented. We tend to like these documents discussed on the list so we get feedback and people can form an opinion about them and ask questions before we bring a presentation to the mic.
We have someone in queue, Paul.
No, the echo is only to us off that wall. Is that what you...
I was saying we have somebody in queue
Oh,
who
in
wants
queue.
to share
Oh, sorry.
slides. I'm a bit surprised by that.
We'll decline it. This session is recorded. Please join using the on-site room. You need to do this, or else we may get a small room in which we hold TSVWG, which we don't want, obviously. So please, no, please seriously, join the online tool. The on-site tool will give you the ability to join the queue, and then you can ask questions of the presenters or the chairs.
On that note, Gori, I notice you're not in the participants list on MeetEcho.
I'm not on the list? Okay, that's because I have a different tool open. I can join. You do the agenda, would you, Martin?
Yeah, this is our agenda. We will start with some updates regarding our drafts and RFCs. We will then move on to our working group items. We get an update on Careful Resume, including 2 presentations from the hackathon that are not on this slide. We will then discuss L4S and NQB, and then we'll have a beverage break. Once we come back, we will continue with L4S and then talk about SCTP. And there have also been some recent developments that are not reflected in the slides yet, but we'll get to that later. We have a third session this week, which is on Friday. We will probably only need 1 hour, but that remains to be seen. We will discuss the drafts that are here on this slide.
So for these particular drafts, please do look at them ahead of the meetings. It's always good practice, but these particular drafts are being put up here as individual drafts for consideration by the working group, and we need eyes on them, please, before we get to the Friday meeting.
Okay. We have some good news for you. We have published 3 RFCs since the last IETF meeting. That is the encapsulation guidelines for ECN. That is the RFC 6040 update and the zero checksum RFC, the zero checksum SCTP RFC. We currently don't have any documents with the RFC editor, and we have 2 documents with the IESG. So we hope that we can publish them as RFCs pretty soon.
So on multipath DCCP, I'm the document shepherd. For this one, we are awaiting a revised draft in response to all the comments collected from reviews so far. And we're going to use the issue tracker to track these comments. And when all the comments have been addressed appropriately, we will then be returning that back to our AD for continuation on the publication request. UDP options is currently on hold, waiting for UDP options DPLP MTUD. So
yeah, I'm the document shepherd for that, and I will do the write-up there. And we have one more document, which is the NQB document where Gori is the document shepherd.
And we've just been through a consensus call for that one. We will be talking about it briefly here, but we expect to do a publication request after this meeting. A working group last call is expected for these 2 in the period, next period up to the next meeting, I think.
Yep.
Which leaves us with these items. The L4S operational guidance, talk about later. Authenticated chunks for SCTP is in the list of materials. And then there is the DTLS for SCTP, which Martin's looking after officially.
And which we will discuss in the second session today.
These milestones were updated, so hopefully they reflect the current status of the group. The whole process here, we've been publishing drafts, sending them to our area director. The quality of the drafts when they proceed forward in publication largely depends not on the editors, but on the reviewers. Please do read documents in the working group last call. Please read them in the working group and pass comments. I'd really encourage people to respond when there is a request for comments. It doesn't matter what your comment is. It could be, I find this difficult to read. I find this a little bit confusing. I think this might be wrong. All of these are really useful because they usually indicate that text can be improved. Of course, many editors actually love you to make a suggestion of what the improvement might be because that eliminates a cycle. But really, I'd encourage people to review documents. It's the best way to get into the IETF process. You don't have to review the whole documents. Anything you see that helps the working group progress is very much welcome. There were a number of activities going on which relate to the WIT area. One was the HP1 BOF, which you may have visited here on Monday, related to high performance wide area networks. So that work may eventually arrive in other IETF groups. So have a look at that. That's already happened. SCON is meeting for the first time on Thursday, and the Deep Space is meeting on Thursday also. Deep Space highlighted because this is an INT activity, although there has been some transport activity related to this that's not part of that group. And is that our last slide? Anybody got any questions about the agenda or anything they think we've missed that they'd like to raise for the attention of the working group?
Doesn't look like that's the case, so we'll move on to our first agenda item, a careful resume. Are you going to present?
No, Mark Ruffalo will present. Go along, have a microphone.
Big stage.
Big stage, yeah. Lots of lights.
Okay, so this is the update for careful resume. The complete title would be careful resumption of congestion control from retained state. And these are the authors. So next slide. This slide, just to remind you what careful resume is a method to start up a connection. Any transport connection is transport agnostic, faster, using parameter from previous connection on the same path. And in this graph, we have some Q-log traces. So we see that the top graph is when the jump, we call the jump when we reuse the previous BDP to start up faster. When we jump at a higher rate, we first validate the RTT, and then if the RTT is consistent with the previous seen RTT, we jump faster. But if this jump would overshoot, because maybe during the intervening period there have been some modification to the path would be different, then we have a more aggressive reduction of the congestion window, and we have a phase that we call safe retreat, so when we reduce the rate more aggressively. Okay, next slide. So essentially, in this now I just wanted to talk about the changes. We have done a few changes, but minor changes, effectively, because we think that the draft is almost ready to go, actually ready to go. So V10 is the last version presented at the last IETF. V11 is the current one. Here we have 4 bullets. The first one is just in section 1.5. Section 1 is really the introduction. So this is a section that clarifies design principle. It's a section that earlier was removed because we thought it was redundant, but after some rethinking, we thought to reintroduce it because it's useful to clarify the motivations and also how we got to this draft. So the second one perhaps is a little bit more interesting because it's changing, clarify a little bit what, how do we transit between the phase and the reconnaissance phase where we validate the RTT and the unvalidated phase where we jump at high rate. And this comes because we have been testing careful resume quite extensively. And one thing that we noticed is that the draft was a little bit too rigid in defining the exact timing of when we can have this jump at high rate. Essentially, there may be different architecture for the transport, the sender. It may be that the congestion control updates happen when you receive an acknowledgement. Most of the transport, for example, in, TCP, Linux TCP that does take a congestion control decision when you receive an acknowledgement. In our case, we mandate to change the congestion window when we send something. So it was an update to the, so we recommended to change the congestion window when a certain condition happen, so that the transmission is limited by the congestion window, as I try to send an additional packet, but packets are in the buffer, but I cannot do it because the congestion window will limit. So essentially, this is too rigid because if we need to accommodate different implementation, now we essentially decouple the decision to change the congestion window and the transition from the reconnaissance phase to the unvalidated phase, which is the jump, as I said. So we decide to do this modification. So the final state machine effectively remain the same. Well, so the moment where I transit from one state to another is the same, except that the congestion window can be modified in advance, so that we avoid some bad interaction between the application and the transport. For example, in those cases where the application is notified to send down more data and to fill the buffer only if something happens in reception. So in order to do this, we had to change a little bit the test in one section, and we have now the condition that specify that pipe size need to be equal to the flight size rather than the congestion window when we enter unvalidated. So there is this technicality where instead of the flight size is effectively, should be effectively equal to the congestion window because we are fully utilizing the link, but effectively in this case, it will be more precise to define it like this so that we can do this decoupling. So then we add in another bullet to say to have some consideration when careful resume is used with BBR. Actually, they were already there. So now we are treating this consideration as guidelines in case this careful resume will have to cooperate with BBR. Careful resume is expected to work with different underlying congestion control, and BBR not being a standard doesn't have to have a normative text, but we decide to anyway to introduce in implementation consideration section a number of considerations, the most important of which is to essentially notify BBR with a flag that we are using, we are in a phase of careful resume that is not normal. And finally, there is a change on the safe retreat. So when we reduce drastically, we try to estimate the pipe size. So counting the acknowledgement, we try to estimate the bandwidth. And before we had a reset of the SS trash when we resume normally, which was equal to 1. Now we have introduced a beta that is essential, the beta that we have, for example, in Cubic, and we allow a range of value between 0.5 and 1. Effectively, sensible number would be 0.5, 0.7. But we allow this this more flexibility, so we don't mandate effectively a number in this draft to reset the SS trash when we resume in normal state. That will be another slow start after exiting the recovery phase. Next slide. So essentially, these are small modifications of what we've been doing. Really, we have been testing our implementation of Careful Resume. We have an implementation for PicoQuick, another for Quiche, Cloudflare Quiche. So in this, I want to acknowledge Jorg and Matthias from FAU for doing all these tests, and Anna and Mihail at University of Aberdeen. Essentially, the testbed is similar, where we have a server and a client, and we have a number of intervening links in between. Of course, we are more interested in networks where the bandwidth delay product is high, that as we know, it can be large RTT and reasonable bandwidth, or large bandwidth and reasonable RTT, but the product of those is large when we have a big BDP. We think hundreds of packets. Next. So here just a few graphs where we tested the different link. While we can see that these box plots show that when CR is enabled, we can have benefits normally when we restart on the same link. So even if the RTT is not measured in over 4G or 5G link, we can have essentially the same level of ratio with respect to the median duration of a completion time. So benefiting in terms of a shorter time to send an object. So in this case, we have sent 10 megabytes, which is kind of large for the kind of benefits that we want to see. The benefits changes depending on the object size. Of course, if the object is very, very small, there is no benefits, because if it stays within the initial window, it would be sent in the same time. And also if it's just twice as large as the initial window, there would be no benefit effectively, because transit a higher state would give essentially the same amount of time to deliver the object. Next. But then when we try to increase over a range of object sizes, we see that there are benefits effectively. These are test for graph test over satellite for geostationary satellites. And we have the orange line is our Careful Resume. And the reason one line, that blue line, is HTTP2. So it looks like that HTTP2 is better than Quick with HTTP with Careful Resume, but that's because HTTP2 and TCP benefit in this case of the TCP acceleration and all the other acceleration that you have over these geostationary links that are not necessarily related to congestion. So effectively, the performance of Careful Resume approach this line, but is a little bit above this. But when we disable this, and for example, in this in the fourth graph here, labeled NetM, is when we have just a delay and RTT with no support for the TCP connection. In this case, the performance of HTTP2 is much, much worse. So we can see that there are 3 to 4 RTT advantage. And well, and this is also better than, of course, the PicoQuick version with just cubic and iStart, which is the green line. Next slide. So yes, there are more tests. In fact, well, we have done several more tests. Not always we improve. Sometimes we have more or less the same performance, but the message here is that we have not seen any damage to the connection. We have not seen any loss of performance when we essentially we have tested on different networks. Next. So yes, that's the last slide. So we have addressed several review informally. We have answered to several questions. So we have done also some other tests with different browsers, testing H3 and testing well, a layer of web layer on top of Careful Resume. Well, after all this, we think that this is ready for the last call, as Cory was mentioning before. This might be proposed as a completed piece of work.
So, questions?
Can I ask a question? Yeah. I think it's great work. And I believe if you go back a few slides and show these results with 5G and so.
Ingmar, can you talk very slowly? We have a lot of echo at the front.
Okay, I'll try to avoid talking with an echo. And if you go back a few slides, it shows that we have this, not this one, but the previous one that showed the 5G. So even earlier. In this case, if I do I understand it right that you get degraded performance with the Careful Resume?
Yeah.
I think, okay, so if you're thinking about the 5G case, there was a lot of variability in the startup of the 5G case as slow start was increasing. Presumably the cellular bearer was somehow settling its resources, and that triggered high start, I think, in these cases, which is why we get this big variation. Occasionally the high start algorithm tripped, and then when it tripped, you were clamped to a smaller window than you expected and grew badly. Now, the interesting thing perhaps is that when you use Careful Resume, it did a very careful test of initial window, measured the RTT, and then did a bigger jump, and that was paced. So then the whole transfer was paced, and the cellular bearer, in this case, it seemed to accept it better.
Okay.
I mean, this may well be random data, so alert to everybody, because the cellular bearers are notoriously difficult to know what they will do initially in terms of exact packet timing. Ingmar will know more about this, but I suspect this is not a reproducible result, but it's a set of real measurements for a particular bearer at a particular time of day.
So, I guess perhaps I will try to speak very slowly. And this one issue with 4G and 5G, if you call it an issue, is that in the initial phase you might have larger RTT than when you run when you're up to running with your in congestion avoidance, and that can play a role here. And you have a DRX, for instance, that turn off radios, and you have scheduling impacts also that. So you might inflate your initial RTT based on that. So, yeah, thanks.
So the person doing the cellular measurements was Anna, and she'd happily talk further about them. Perhaps the most encouraging thing is things that weren't worse using the method.
Yeah, okay.
Right.
Thanks, Ingmar.
This is Rüdiger Geib, Deutsche Telekom.
Can you please get in queue?
Let's just put Rüdiger in the queue. Other people, please join me. You're done. Go ahead, Rüdiger.
I'm sorry.
Fine.
Yeah. I've been reading the document, and I think it's a very useful draft, and I think it should progress. One thing irritated me a little. There has been a section called endpoint information where you mentioned that this could be consisting of IP addresses and also DSCPs. DSCPs are carrying usually a local information, and they might not travel end to end. So you should add a note at least that this is not a reliable end-to-end information, and an IP address might change. If you have a NAT in your connection, and I'm pretty sure that IPv4 to IPv6 transition will see nuts. So this is not useful endpoint information in all cases. And it might be worth adding an information on that.
I think what you're talking about is the view that the source of data has of the path it's using, which, if I remember right, was an endpoint token originally that identified what that path was to the sender. Yeah, okay. I mean, clearly, if the IP address changes, that path is no longer the same. It could be the same, but that's hard for a sender to know.
That's not what I say. I say on an end-to-end path, the IP address might not stay the same, even if everything stays the same. So what the sender sees might not be what the receiver sees, might not be what the sender has sent.
If I understand correctly, this endpoint information is not communicated over the wire. It is just a local identifier that you use to identify the path that you're using. And if anything changes, the safe thing is to not use any stored information.
That makes sense. Thank you.
Maybe we could check the word local appears in the right place.
Yes, thanks. Yes.
Okay, we could probably usually take Kazuho's talk before we talk about whether this is ready to proceed. Kazuho, are you in the room? And just stay here if you like, it's up to you.
What's the name of
The next slide deck. 3-1. Okay. So we have two very micro talks here from the hackathon activity, just related to this because we thought this was reaching some level of maturity, so we took it to the hackathon. Go ahead, Kazuho.
So hello, I'm Kazuho Godfastly, and I'd like to talk about our careful resume experiment that we did with our production servers. So, as you know, careful resume consists of two parts: remembering the previous throughput and resuming at the estimated throughput. So we wanted to make sure that the second part of the resuming algorithm performs well enough so that even when we fail to estimate the correct bandwidth, it doesn't make us any harm. So to achieve that, to confirm that, we just hard-coded the careful resume CWIN or the window size to 60 packets, regardless of what the connection was, and compare that to IW30 or IW60. Because the reason we chose IW60 as well as IW30, which is our baseline, is that by comparing CR6 careful resume at 60 packets versus slow start at 60 packets, we can tell if the complexity introduced by the careful resume is necessary or not. And we actually deployed this ABC testing in one of the POPs in Europe and ran it for a couple of days. And to collect only the connections for which we had enough pressure to the congestion controller while during the slow start or the startup of the connection, we filtered the connections that had at least 200 kilobytes of HTTP response as the first strict response, which was served from our local cache, because otherwise, if we're getting the information from other servers, then the bottleneck would be there. And we also excluded connections that we saw any receiver window blocked behaviors. And then for those connections, we collected the TTLB, the time to last byte of that first HTTP response, and then compared the results between the three groups. Next, please. So this chart, maybe it's a bit small, but draws the 3 lines of the CDF. So the purple line is IW60, and the blue line is CR60. And the black line is the baseline, which is IW30. So if you look at the right side, at the below, it focuses on the 50th percentile. And as you can see, CW60 is performing about 30 milliseconds better than the IW30. And as you can see, IW60 is in fact slightly better than CR60. And this is because in case of IW60, we do pacing at half an RTT, whereas in case of CR60, due to the algorithm, we we split the packet across the full RTT. So it's a kind of expected result. But as you can see, at 50th percentile, CR60 is performing well. I mean, like almost reducing by 1 RTT as we expect. And if you look at the 95th percentile, it gets more interesting because CR60 is performing a bit better than IW30, but IW60 is performing much, much worse compared to the other two. And there could be multiple explanations. I'm not sure what the actual result is, but it's clear that IW60, due to, well, IW60 having negative results. So the complexity of CR60 is probably justified. And I'd point out that for this 95th percentile group, most of the connections had really small congestion window size, like 10 to 15 packets or something. So it's likely that in the case of IW60, we are doing multiple reductions. I mean, starting from 60 packets to 30, then to 15, and blah, blah, blah. Whereas in case of CR60, we are doing safe retreat directly to the bandwidth. So it's most likely that that complexity that we added to careful regime is actually providing us the necessary benefits that we need so that careful regime performs always better than ordinary slow stats. So I think we have a pretty good results. Thank you.
Okay.
Oh, sorry, could you go to the next slide, please? Oh, I'm sorry.
Yeah, one more slide.
And sorry, I forgot to present this next slide. So this slide shows the CDF of packet loss ratio. And as you can see, CR60 is at the middle between IW30 and IW60. So the packet loss ratio is kind of expected. And because most of the connections remain in slow start or exit right after slow start, the ratio at the tail might look a bit high, but this is kind of expected. So thank you very much.
Okay, any questions for Kazuho? I'm sure he'd be willing to talk to you if you have any questions about Fastly's implementation or the results they've gathered. Thanks very much.
Thank you.
Can I try to share?
You need to request that.
Just try. Did it work?
Do it again.
Okay. Oh, confirm. Wait, what the heck? Wait. That's not this one I need to press.
Do you want to do the slide share or the screen
I want to
share?
do a screen share. That's why. Allow. Chrome's entire screen would be quickest. Allow. Did that share? Yeah. Okay, this was just to follow up on the hackathon where we did some live tests. So what might that actually mean? Anna showed this in the hackathon, but she wasn't able to show the video. So I promised I would just show the quick video clips here. We have 3 implementations that we know of the method, one with Fastly that Kazuho reported on, one with Cloudflare Quiche. So this is a Cloudflare Quiche demo taken at the hackathon with a 10 megabit per second path and 600 milliseconds RTT, which is the base test for the residential geo satellite service. And when you press the download, it goes like this. Just in case you thought saving 1 and a bit seconds wasn't worthwhile, it actually appears quite obvious when you actually do a web download. This is from the H3 server using a Safari client. And here's a Pico Quick one. We tested both. This is with the Chrome client. Again, same path, using this time Chrome with the Pico Quick version. And again, you can see Careful Resume loads the page faster. Just in case anybody was questioning whether we had real implementations that actually worked, we have real implementations that worked with standard web browsers. And I think that is all I wanted to share. Just to pass that on from Anna. Okay, which brings us back to the working group status of the item. And a question to Martin as chair as to whether this might be ready to proceed, as roughly asked.
What about
You don't need that
document?
slide deck. No,
Okay,
that,
okay.
that was the video. So basically, Rafael asked if the draft is ready to proceed. Do you want to ask any questions? Maybe who's read it? And see if
Do you
we're
want to
ready.
do a show of hands?
Yeah, let's do a show of hands. So we will move to the show of hands. I'm re-putting on the chair hat in case you're confused about what's going on here to help Martin. We're going to do a show of hands, first of all, for what?
Who has read the careful resume draft? Well, I should have asked this differently. I should have asked, have you read the draft? Now the result disappeared from the screen, but this was 14 people have read the draft. 25 have not, but 14 is a pretty good number.
Who thinks it's
Yeah.
ready, whatever you contrast?
Now I'm doing it the right way. Do you think it is ready for last call? Okay, that's few people who then have read the draft, but 13 people think it is ready for working group last call, and nobody thinks that it's not. So yeah, we will start a working group last call on the list after this meeting.
Thank you, Rafael. Thank you, Martin.
Do you want to switch the items around so David can?
Yeah, maybe can we take NQB first, just to ensure that David can join remotely? David Black said he would join if we did NQB in this session. Is that okay, Greg? Yeah, I see Greg coming to the mic. So I guess I should introduce NQB in that this draft has proceeded past working group last call. There was quite substantial feedback in terms of volume, if not in terms of technical changes. And some technical changes were made, so we did a consensus call. So that's the stage we're at. That consensus call is now completed. Over to you, Greg, to talk about the draft.
All right, thank you. I won't go over all of the history of this, but just point out that this draft started its life over 6 years ago as an individual draft. And as Gloria said, just had a working group last call earlier this year. The last IETF meeting, I gave an update. At that point, we had resolved all of the comments from working group last call, save a few that were open issues, and worked in the interim to get those issues closed. At this point, all of the issues that had been identified at the time are closed, and that led to this draft 26 that completed the consensus call at the end of last week. And maybe go on to the next slide, actually. The updates since the last IETF meeting to address all of those open issues are listed here. I won't go through them all in detail, but they're there for the record. And as is usual, you can do a delta on the data tracker as well to see the specific changes. That leads to the next slide, which is the only two next steps that came out of the consensus call were the addition of one sentence in section 7.3, suggested by David Black, and then to remove Sebastian Muller's name from the acknowledgements section. And what remains is the review comments from the document shepherd. So Gory's already done his review and sent comments to the mailing list. So that was last night, I believe. So we'll get those taken care of and proceed with the requesting the publication. I do see we have David Black in queue.
David, go ahead.
Okay, so this is David. I'll confirm that we have resolved all of the issues that I had open as of the last meeting. It's not exactly been quick or a direct path to resolution, but we got it done. The result's okay. I can live with it. As one would expect this kind of discussion resolution, it's not an ideal result for anybody, but it will get the job done. And I want to thank Gory for putting the very last chunk of text into his Shepherd comments as well, providing a belt and suspenders assurance that it will get done.
Okay, thanks, David, for confirming that. So I guess from my part, the consensus on the changes was that the working group would proceed with requesting publication. It was rough consensus. There was one person who wanted to withdraw from the being a part of that consensus, so it wasn't complete, but it's sufficient judged by the chairs to proceed the document. So we will hopefully see a new revision with those changes incorporated.
Yes, very soon.
Okay, as soon as we get those revisions and the answers to the Shepherd's questions about publication, then we'll produce a Shepherd report and we'll ship to our AD, who will doubtless also do a review.
All right, thank you very much.
Thank you for completing this after all that time.
Yeah.
The next talk will be Jason.
All right, thanks. So giving a quick update on our low latency trial and now deployment. So next slide. We certainly appreciate all the involvement of our partners. It's been really helpful to get quality of experience data from them, application layer feedback, and that's been incredibly important. As well, I'd also like to recognize the very small core team that we actually have working on this. You might think at such a big company it would be, we'd have 150 people working full time on something like this, and it's really not. In addition to my limited time, it's Jeff, Mike, Chad, Eric, Takahashi, and Leslie, and we recently added someone named Rana who's helping us with some data analytics issues. So we really appreciate all of their effort. Next slide. So this is a bit of an eye chart. I'll give where we are now, or where we've been September, October today. Mid-October, we deployed into production. A PPOD is our funny name for a virtual CMTS. So that means that we deployed to 3 production CMTSs. That's a little bit under 20,000 users that are on those devices that got L4S and then QB service, so dual Q. And we are preparing to go to the next phase. I'll talk about that in a moment, about how those things go. We've also done a big push. We have more than 30 million broadband customers. So whenever we make a change, we need to do an educational push to our frontline employees that interact with customers every day. So we've done some educational things for them so that they understand what latency is and what we've done to try to improve that. And then next year, late this year to early next year, we'll expand beyond the initial 2 Comcast managed devices to a 3rd device that has huge numbers of people, which is called the XB6. And then in first quarter of next year, we'll add customer-owned devices, which we would call retail cable modems. Next slide. So how are we doing this? It's in a few phases. We're currently in the sort of crawl phase, if you will, and then we go to walk and run. And in essence, we start off with a small number of production users. We let that soak. We look at lots of operational statistics and make sure that everything appears to be within normal ranges before we move on. And that's typical of any kind of deployment. But very quickly after initial deployment, we go into full deployment. And as we get into that phase, that's going to be in the order of like 500,000-600,000 homes every week. So that'll be a pretty big deal. We hope to get to that phase before end of year, depending upon change moratoriums. Next slide. Just to give an example of some of the monitoring that we do, it's a mix of network telemetry, sort of at the link layer as well as at layer 3 and above, both passive and active tests. And so there's a whole bunch of stuff, and these are the normal things that we would monitor for any big network change. So it's everything from our smart nodes, which are called remote PHY devices, to the virtual CMTS, to cable modem health statistics, to active tests that run from those home gateways, which include speed tests and latency under load tests. We also have a service gateway where we can observe things like round trip times so that we can do some passive estimation of QoE. And then, of course, we look at the typical things like, are customers contacting us? Are there trouble calls related to this? Are they mentioning this term in chats and so on? And then, of course, typical layer 3 and layer 7, mostly layer 7 is from partners. So a whole range of stats, and the good news is that so far in the first few weeks, everything is within normal range, so we don't have any concerns. Next slide. So from our standpoint, we're ready to scale, and we're getting ready to go to the next phase right now. We're actually, because of the US election, which is, my God, today, we are in a change moratorium because it would sort of be a bad time to do something and cause the network to go down. So we're waiting for that moratorium to end before we move ahead. The other thing worth noting, and this is where some things get very interesting, is that obviously downstream AQM enablement in the CMTS is tied to the deployment of dual Q L4S. And as a result of that, we have that feature enabled and turned on, and we did have it enabled and turned on in our CMTSs to get ready for this, independent of dual Q being turned on. And so the interesting result that we noticed was 99th percentile latency under load and downstream, basically halved from 50 milliseconds to 25 milliseconds. So great result, similar to what we've seen in upstream. But it had some very interesting effects on some of the stats that we watch. And in particular, we have this gateway speed test. And so it's code that's embedded in the home gateways. It periodically runs scheduled tests of speed and latency under load. And the interesting thing, two things happened when AQM got turned on. One was that there was a slightly more sort of oscillation at the high end of the utilization of the link, where it was sort of hunting a little bit at the max bandwidth level. The other was that retransmissions basically went to 0. And so both of those things concerned folks, and they said, hey, let's go look into it. And so I did spend some time explaining that not having retransmissions is a good thing. Like, we don't have a normal amount of retransmits that we have to maintain or something like this. And when we looked at third-party tools, we did not see the same effect. And so we basically said we have a bug or an issue in the configuration of our existing tools, and folks tested it in the lab, and we basically needed to add a few seconds of runtime to that test, and everything went back to normal. So good news story there, but it was amusing when it occurred in a lot of ways. And in addition, when we see L4S and NQB with AQM as well, those things are all performing upstream and downstream as expected. And the packet delay, so this is really the the packet time across the CMTS interface. So very, very local to the CMTS, not really all the way to the user home. But we saw some, dramatic changes in those latencies, which, were surprising, I think. But we'll see. And the app developers that we've been partnered with are all, reporting, pretty good benefits so far. On the other hand, the deployed population right now is relatively small. So it's hard for them in production to discern, this number of users from the, broader population of broadband homes. I think we have a couple questions.
Yeah, let's take the questions first. Mo?
Mo Zanatti, can you comment on what applications were enabled for this?
Sure. So FaceTime is enabled. We have another app partner from Meta that has another real-time application called WhatsApp that you may have heard of. Then we've got folks from Netflix, NVIDIA, and Valve also.
So it's audio and video calls and then some streaming applications too.
Gaming primarily, yeah. But I'm going to show something in a moment about video streaming.
Thank you.
Yeah.
I'm sorry. This is not a typo. Those factors are 2,500 on the latency, or is that 950.95 milliseconds?
Microseconds.
That would be
so this is across just like within the CMTS.
Okay.
So
Cool.
it's a very.
I got it.
Super small.
Still, like 3 orders of magnitude. That's amazing.
Yeah.
Okay. Cool. Thanks.
Yeah.
Stuart Cheshire, not a question, but I think it's important to say thank you for doing this work. You've stuck your neck out and taken a risk and really worked for a long time. You and the rest of the team at Comcast, it's always risky doing something first in the industry in case it goes wrong. So thank you for doing that.
Yeah, our pleasure. Next slide. So next steps, and then I've got one more thing, as the Apple folks love to say. So, we're at the point where we're gradually widening the scope of the production deployment. And then, as I said, we'll add more customer premise equipment models, so more cable modems. And, I'm spending a bunch of time, out evangelizing, trying to help developers adopt, trying to help other ISPs adopt. It's also been interesting to open up a lot of conversations, both internally and externally, with developers about all the assumptions of delay that they always have had, and what would happen if you took away some of that delay. So an interesting thing happened in talking with some of our executives about latency. And as many folks might know, bidding for broadcast of sports rights is kind of a big deal. And it's one of the things that video streaming platforms have, competed against traditional, video distribution companies, and rights for whether it's Premier League or the NFL or whatever it happens to be, are constantly getting bid up. But there was an interesting question, which was, could you apply both low latency networking and other forms in the sort of delivery chain to reduce latency, other tools where your live sports event could be very, very close to live compared to other provider platforms. And the example was, like, let's say you lived in an apartment, 2 apartments next to each other, sharing a wall in the living rooms, and they're watching, the Super Bowl, and all of a sudden, like, one apartment hears the other cheer, oh my God, and they're freaking out. And then one apartment's like, well, why are they cheering? Like, what happened? And then like 30 seconds later, they see the thing, they're like, that's what happened. And so that's an interesting thing. And so we've been playing around with that. Let me see if I can share the screen here. Do you have to give me permission?
I just did.
Just did.
Is it showing up? I'm granting it. It's not doing anything.
All the slots for requested media are already taken. And you maybe don't share your slides. There's something.
Oh, ask slides?
Let me close the deck.
Martin had the slides.
Martin was doing it.
There you go. Okay. There you got it.
Okay.
I now have
no, no, no. That's not a screen share. You want to. You don't want slides, you want screen share. Yeah. And Martin says yes. And now you've got it. Now you have to. Are these your windows? Yes. Just entire screen's the easiest. While Jason clicks on various buttons in his user interface, we'll take Jason's contribution to the end of this talk, and then we'll have a break where we'll let you all disappear down 4 flights of escalator to get a cup of coffee or juice or whatever it is, and then we'll resume here in the same room afterwards.
All right, hold on. This is actually very interesting.
You got it?
I had to restart Chrome. Sorry.
Wrong meeting session. You want to join on the client? Do you want to take the break and show it immediately after the break?
Yeah, we'll show it immediately after the break. Sorry.
So this is our amazing short break. Check the agenda. There will be beverages available downstairs. Please go if you like. Please check your email, and we'll resume with Jason's video and then the rest of the proceedings.
I think it's because it's 1 minute after. That's fine.
Yeah. You get locked out. It's fine.
I timed out. Okay.
Are you going to drop the session?
I don't know. We'll see what MeetEcho does.
Yeah, I think you have to drop it. It's a new session.
Okay.
I wonder what happens if you open. Do you power it up in the new one?
No, not yet.
Interesting.